Okay, in this particular lesson, we're going to talk about exactly how humans impact our environment and the emphasis that we have on what we do in our environment. So, things I want you to think about is whether you've ever thought about the problems that face our environment today, and exactly how much time and energy we spend in fixing those problems that we have. Then we think about all the money and time and energy that we spend fixing them, and you realize that for many of them, we're the ones that created them. So we're fixing what we've actually created instead of just stopping creating them. So some of the problems that we have or that we've created in our environment: acid rain, the hole in the ozone layer, global warming, chemical pollution, etc. So I want to know whether or not this particular picture looks familiar to you, whether or not you've seen any forests that look like this. This is an example of acid rain and the damage that acid rain can do to our environment. So exactly what is acid rain? Acid rain is sulfuric acid that's falling from the sky. So sulfur is released from smokestacks, right, from factories as a waste product, as a pollutant product. That sulfur gas mixes with water vapor in the air, and as it mixes, it starts to create sulfuric acid that condenses, it cools, and falls back to Earth. And when it falls back to Earth, we refer to it as acid rain. I'm sure that sometimes you've heard about acid rain and the damage that it can cause, and you may have even heard about pH relating to acidity. And the pH, or how acidic something is directly related to the amount of water vapor that sulfur is mixed with. So imagine what could happen to the plant life when sulfuric acid falls on it, and it seeps into the ground, and the plants soak it up through their roots. And basically this acid is polluting them on every level and killing them. So how about other types of water pollution? All right, I'm sure that you've probably seen some places that look like this. You may have rivers in your local communities that look similar to this. And dumping, the idea of people, and dumping can be, you can talk about garbage. You can talk about chemical dumping, right? Runoff being all of the different things that come from a particular area. Many times, runoff, what's in the runoff can be pesticides. So we're talking about chemicals. This is another picture showing, as you can see, some incredible runoff that's leaking into this water or seeping into this water and polluting the environment. Anybody thirsty? Hopefully not. Some Fanta? No? Look at all of our plastic water bottles. We pay for our water. So think about where your water comes from. All right? Is it from the ground, a city reservoir, a water treatment facility? And basically, no matter what, you need to know that your water comes from the sky. Okay? We should know that groundwater evaporates. We get water vapor that condenses, becomes rain, which is our precipitation that seeps back into the ground and once again becomes that groundwater. All right, and by groundwater, I'm talking about, it could be the water table in the ground, it could be lakes, ponds, streams, rivers, we could be talking about the ocean, but ultimately it's important to know that the water that's here is the same water that's been here for many, many years, and that it just goes through this constant cycle, what we refer to as the water cycle. All right, so here again is our water cycle. So we've got that evaporation process. Transpiration is what happens when plants lose water, right, through the same process like an evaporation, but it's evaporating out of the plants. So again, it winds up in our clouds as water vapor, and then it condenses to become rain precipitation, which falls to the ground, and then it's going to trickle down into our ground. So it's important for us to take care of that water supply, right? because water pollution is this big problem that we have where ultimately we drink it. It's coming back to us. So the more damage that we do, we're only really hurting ourselves. It's also important to notice that we use our groundwater fast, a bit too fast, faster than the water cycle can actually replace it. And that's largely based on the different ways that we are consuming our water. Think about all water that's probably stored in bottles right now, not being utilized, stored on shelves in factories, etc. And they're being removed from that cycle, and therefore the cycle is being depleted. All right? So just emphasizing that it's important for us to take care of that water because it's the only water that we're really going to be getting. Our ozone layer. All right? Ozone is a part of our atmosphere. All right? Its job is to filter out UV rays. I'm sure you guys have heard about UV rays. Many times they're advertised with sunscreens. And those UV rays are intense. They create a lot of heat. They can be damaging. And the ozone layer works as a big giant filter to kind of block out some of those harmful UV light rays. All right? It's made of O3 gas. All right? So not O2 as in oxygen, but O3 is ozone. And because of the weight of that gas, it flows to a specific altitude in our atmosphere, and it creates this layer, right? Almost like this insulation layer. So here's our ozone layer. Like I said, it's an insulation layer because the heat that's inside gets to remain inside and just kind of bounce around inside our atmosphere. But at the same time, it's also a filter layer because, as you can see, we've got sun rays that are being bounced back. All right, being bounced back at the sun because it's not being able to pass through the ozone layer. So, you've probably heard about the hole in the ozone layer. It's important to recognize that chemicals that we use, all right, we call those chemicals CFCs, all right, they break down ozone molecules from our atmosphere, and that results in depleting the ozone layer. All right, but the important thing is to notice that ozone is a gas, and you can't really cut holes in gas. All right, so, all right, like I said, CFCs, chlorofluorocarbons, chlorofluorocarbons, CFCs, right? They're often found in refrigeration and cooling units, air conditioners, refrigerators, freezers. And what actually happens is that those CFCs, as they escape and they travel up to the ozone layer, they interact with the ozone layer, break down the ozone molecules, and the ozone molecules are no longer a part of that ozone layer, which means the layer as a whole is depleting and getting thinner. The nice thing, though, is that there's been worldwide efforts to decrease the use of CFCs. All right, there's been attempts at diminishing how many CFCs we're really using and releasing into our atmosphere because we don't want to continue this problem. All right, so basically, this thinning is going to become a problem. All right, that problem is directly related to global warming. Our global warming kiosk, or our global warming lesson, will follow shortly. But it's important to recognize that that layer, which used to be, substantially thicker, used to bounce back tons of sun's rays, right? And only a few were able to get through. Versus, as it gets thinner, more are going to be able to pass through, and less are actually going to be bounced back, which means we get a lot more heat, right? So, seeing soap running into the drain from a car wash, oil on the ground in a parking lot, dumping by a company or a factory, and just recognizing that these are all forms of chemical pollution, which is very broad, right? Chemical pollution, we can talk about pesticides and runoff. We can talk about the hazardous materials, toxic materials that are placed into dumping sites. Right? Chemical pollution is a really wide range. Oil spills can be considered a form of chemical pollution. I'm sure oil spills are a relatively relevant item, especially with our recent oil spill in the Gulf. And the idea that those oil spills have drastic effects on the environment that they're in, right? So the impact that they have on the wildlife, it may be on the water quality, the food quality. If they're contaminating everything, if that oil spill is contaminating everything, it becomes a problem for all of the organisms in that surrounding environment. We do have methods to clean up these oil spills. Really interesting fact is that we have oil degrading bacteria, right? They actually are able to eat the oil, break it down, and that actually can help with oil spills, or sometimes this type of bacteria is found in eco-friendly drain cleaners, because eco-friendly tries to diminish that chemical pollution, so instead they use a biological method of cleaning instead of a chemical method.